Hello, and welcome back to the Carbon Capture Magazine podcast. I'm your host, Danielle Piekarski, and today I am joined once again by Ben Cannell, Innovations Director at Aquaterra Energy. Ben, thank you for joining me on the podcast. We are excited to have you back.
Thank you very much. I'm excited to be here.
Of course. So for anyone who hasn't tuned into the last podcast that we had you on, would you briefly tell our listeners about yourself, what you do at Aquaterra Energy, and what Aquaterra does as a company?
Yeah, of course. I'm the Innovation Director at Aquaterra Energy, and I look to bring new products and services to the marketplace and also support and improve some of our existing products and services. Where Aquaterra fits into the overall marketplace is typically offshore related, between the seabed and the surface, is where we have products and services that fit into that piece. The kind of things that we look at are to do with dry tree developments for minimal facility platforms that we design and install around the world. We also provide systems for jackup rigs and light well intervention vessels to support intervention and drilling activities or converting jackup rigs to do subsea work. And of course, we're active in the renewable space with green hydrogen production offshore wind, and legacy well re-abandonment, and all things to do with carbon capture and storage projects.
Great, thank you. So today our focus is going to be subsea well interventions. So could you explain what some key reasons for reassessing the standard approach to shallow water subsea well intervention?
Yeah, so one of the areas that we get involved in as an organisation is the very early phases of well planning or intervention planning. And that will involve typically riser analysis. So we have a team of engineers who will assess weather and operational conditions, metocean conditions, etc. And we'll work out fatigue life and operational windows to complete a particular activity. What we've noticed is that there's some well-established codes which the engineering team have to apply. They're global standards, such as API 17G and ISO 13628-7, which are prescriptive codes for completing this analysis work. And we carry out many different assessments on there. What we're seeing is the need to look at wider equipment and compliance with these systems, but also as well to take some of these technologies forward, where we're seeing assets that may have been put in many years ago in shallow waters with first generation lighter weight equipment now is harder to access with the latest generation dynamically positioned vessels and things like that in shallower waters. And this is where jackup operations or lift boat operations are becoming more important for these types of operation. So it's twofold, really. We're looking at code compliance of equipment that matches the analysis that's completed in the early planning phases, and new and novel approaches to subsea intervention activities using jackups and lift boats, especially in areas that are really borderline for semi-submersibles to complete that work.
So what demographic trends in subsea wells on the UK continental shelf are highlighting the necessity for either well intervention or well abandonment?
Okay, so typically where we have oil wells, they'll require more in-life servicing and intervention activities than gas wells on a broad sense. And of course, at the end of the life of any well, it will require intervention activities to then go on to abandon that well. One of the considerations, especially in the UK continental shelf at the moment, is the options that are available to that well, or the formation that the well is in or passes through for reuse for carbon capture and storage, for example. So this typically won't be reusing the well itself for that activity, but consideration on the abandonment technique to ensure that should that formation that it's entered or passes through in the future wants to be used or repurposed for a CCS storage site, or indeed even hydrogen storage, it's been abandoned in such a way that it will support those activities. And we're seeing that as a common feature, actually, with some of the CCS developments that we look at, where they have this common problem where a well has maybe been abandoned correctly many years ago, but doesn't isolate an aquifer, for example, that's above it that now wants to be repurposed into a storage site for CO2 or hydrogen.
Okay. So, what are some of the challenges that you would highlight associated with older well designs and today's modern semi-submersible systems in shallow water interventions?
Okay, so some of the first generation BOP systems that may have put in these older wells were much lighter, much smaller. These might have been moored semi-submersibles that placed the wells in there as well in the first place. Some of the really old systems that we see are 13 and 5/8 subsea wellheads, and they're essentially marinized surface trees and wellheads. There's several of these from the early 70s in the UK North Sea. And believe it or not, there's also assets like this in the Middle East that were drilled as subsea wells many, many years ago around the same time. So what the features they have is they were designed to support much lighter, much smaller pressure control equipment when they were first put in. And quite possibly some of the considerations weren't made as well for the detailed analysis that happens today. What does that mean when we bring in a latest generation BOP system and semi-submersible that might have dynamic positioning? Well, it means that in some cases, before you even put environmental loading onto the analysis, the weight of the BOP itself can be enough to make the well fail. So considerations then need to be put in place for BOP support, so taking vertical stack tension away or removing it, or in cases where the vertical stack tension can be supported, BOP tethering and other mechanisms. Of course, there are alternatives such as, where possible, reducing the operating window that may or may not be acceptable in certain circumstances. But one of the key issues that we have is the response time in the BOP systems for closure during any drift off with the DP systems. And in shallow water, that's exaggerated because of the time from going in a green zone of operational activity to an area where the system's not failed but is going to approach failure shortly. There's a very, very small window to react and disconnect from the well stack.
Very interesting. Okay, well, to switch to the positives, what are some of the advantages of using jackups or lift boats for shallow water subsea well interventions?
So the main advantage is that you've then got a much more stationary platform with which to access that subsea well. And because it has much less movement, it's generating smaller bending loads and fatigue damage into the subsea well itself. And of course, you can control the vertical stack tension and the sit down weights and the tree or the wellhead as well, because these systems are typically top tension. So we can have a neutral weight at the tree or the wellhead. So you've got a much greater degree of control of the loads that go into the wellhead or the tree system. Another big advantage is the fact that you don't need a quick reacting disconnection system because there's no drift off event that's going to happen from the well itself would be under a controlled process. So you can simplify the intervention equipment that you're using and therefore reduce the weight as well. and you eliminate that need for doing the drift-off analysis that can often be the difference between finding a workable solution and not finding a workable solution for these water depths. There are some challenges to overcome, in as much as the subsea semi-submersible that might be doing the work, or indeed a light well intervention vessel, they are completely set up and used to doing subsea operations and have the equipment with which to deal with that. Whereas a jackup, certainly in certain parts of the world, may have only been working on dry trees or some exploration drilling with surface equipment and never entered into the subsea world or been used to that. So having a competent provider of equipment and services is crucial.
Absolutely. So just to end things out, could you tell us about Aquaterra Energy's new intervention system that has been developed and how it is meeting industry standards?
Yeah, so we saw a need for a large bore system, 7 3/8, that you could complete bigger scopes of work from jackup rigs or indeed light well intervention vessels or indeed semi-submersibles, and pull the very largest horizontal tree crown plugs, for example, broaden the scope that you could do it. And also, crucially, seeing that this gap in the marketplace where often analysis is being completed against API 17G or ISO 13628-7, but the equipment that's being supplied doesn't necessarily meet those standards. We saw a need for a purpose-built intervention riser system that was reusable with replaceable seal rings that would comply with these codes and with the analysis that is being completed. And we've done it in a way that can be used on jackups as well as on light well intervention vessels and other areas. And our belief is there's certainly a place for wire through water operations, and we see that that's a key part of the industry. But having the ability, even for these light well intervention vessels, and semi-subs and jackups, to also access a well via a riser to support fluid pumping and coil tubing operations and others, offers some significant advantages and some significantly de-risks a project. If you just plan to go back to a well with wire through water operations, you could very quickly run into difficulties if you don't have a riser to be able to run in and pump fluids or do other activities. And most of the cost is in the mobilization and demob of these vessels, with the intervention itself often only taking hours or a few days. So we see that there's an important step change in the industry.
All right. Well, we are going to close things out. Again, today we are joined by Ben Cannell, Innovations Director at Aquaterra Energy. Ben, thank you again for joining us today. Is there anything that you'd like to add?
No, that's it. Thanks. Thanks for the opportunity to speak to you again. It's a pleasure.
Yes, thank you. And thank you to our listeners. If you or your company is interested in recording a podcast, please reach out. For more podcasts like this one, visit carboncapturemagazine.com and subscribe for industry news. We hope that you enjoyed this podcast and look forward to next time. Until then.